In this video, we are going to look at properties of midsegments. So we can draw a midsegment in a triangle, and we can draw a midsegment in a trapezoid. And actually in a triangle, we can draw 3 midsegments. So let's take a look at a triangle. So what is a midsegment of a triangle? Let's draw a picture. So here's my triangle, and I'll call this triangle ABC. And what I want to do is I want to find the midpoints of all 3 sides. So I'm going to find the midpoint of AB, and then I'll show that's the midpoint with tick marks. And we'll find the midpoint of segment AC, so that's over here, and we'll give those tick marks as well. And then we'll find the midpoint of BC. So we found the 3 midpoints of the sides of the triangle. So now what we want to do, in order to draw a midsegment, all I need to do is connect any 2 of the midpoints. So let's connect these 2 midpoints. So this segment here, let's redraw that, is going to be a midsegment. It connects the 2 midpoints of a triangle. So let's call this D, and we'll call this E. All right, so we picked 2 of the midpoints, we connected them, we formed a midsegment. Now let's label this point down here F. Let's connect D with F. That's another midsegment. And then our third midsegment that I can draw in is EF. All right, so if you notice here, we now have 4 smaller triangles. So we had the big triangle ABC, and now we have these 4 small triangles. So how do the 4 triangles created by the midsegments of a triangle compare? Well, if you had to guess, it would be a good guess that they were congruent, and in fact they are. And we could prove it if we wanted to, but for right now, we'll just know that the 4 triangles are congruent. So the 4 small triangles are congruent. All right, so that can be helpful for us. And next, the question says, how does midsegment DE compare with segment AC? Looks like I switched these 2 letters, so let's flip A and B here. So let's make this A and this B. Sorry about that. So we're looking at DE and AC. So as it turns out, if you were to draw the midsegment of a triangle, the length of this midsegment would be half of the length of the side that it's parallel to. So how does midsegment DE compare to segment AC? It is half the length. All right, so, and this is true for all of them. So if I was going to put tick marks here, I could put 3 tick marks here, and then let's look at another midsegment. Let's look at DF. So DF and BC, those are going to be related. There's one more relationship that we'll get to in a minute. So DE is going to be equal to one of those segments, and then the last midsegment EF, that's going to be half of AB, so that's going to get 1 tick mark as well. So now if you look at these 4 small triangles, each triangle has a green side, a blue side, and a yellow side. So these 4 triangles we could prove are congruent by side, side, side. All right, so how does the midsegment compare? We already said that it's half. It is also, that's not the bell for your class, that's just the bell for the next passing period while I record this video. It is also parallel to AC. All right, so these 2 informal observations that we made about that triangle up there, we're going to use for the triangle midsegments conjecture. So the 3 midsegments of a triangle divided into 4 congruent triangles. Alright, so here's our 4 triangles over here. Those are going to be congruent. And a midsegment of a triangle is parallel to the third side. And a midsegment of a triangle is half the length of the third side. So we're going to use the fact that these 4 triangles are congruent, the midsegment's parallel to a side of a triangle, and the midsegment is half the side to find angles and lengths of segments. Alright, so that's it for this video. In the next video we're going to move on to a midsegment of a trapezoid. So as always, if you had questions, make sure you get those answered, and we'll see you in the next video.